here we are going to study about the normal axis of the heart and abnormal axis of the heart. First, we are going to cover the normal axis and then abnormal axis. Abnormal axis means right axis deviation or left axis deviation or extreme axis deviation. Okay, the axis deviation actually gives you clue about the hypertrophy of the ventricles. If there is a right axis deviation on the ECG, it means that right ventricle is hypertrophied. If there is left axis deviation on the ECG, it means that your left ventricle is hypertrophied. Okay, so let's jump to the normal axis of the heart. Let's consider I have drawn this heart in 4-quadrant plan 1, 2, 3 and 4. Okay, let's think that it's not a heart. Let's consider it's a human being who is sleeping like this. That is his head, right upper left upper limb, left lower limb, right upper limb, right lower limb. Okay, so we have studied already that the action potential will start from here, SA node, right atrium, it will go to the AV node, and like this it will go down this. So it shows us that this is the normal axis of the heart, like this, from top to bottom. Okay, or I can show you it on a paper. This is the normal axis, how the heart is lying in a 4-quadrant plane and how the action potential goes. Okay, now if you want to study the normal axis, you can study it from this area, right? This is the area, because that's how the action potential comes down. This area can be shown in the ECG by lead number 1, lead number 2 and AVF. See, this is lead number 1, lead number 2 and lead number AVF. Okay, or in other words, you can say that axis of the heart means that how much area has been covered by the depolarization of the ventricles. So as we said that this is the area, it is from -30. Let's consider this is the 0, and when you go to this side you are going to +90. This is the 90 angle, right? So the angle at which the action potential spreads on the ventricle is from -30 to +90. Okay, this is the normal axis of your heart, which is shown to you in the ECG by lead number 1, lead number 2 and AVF. Before jumping to the axis and axis deviation, there is one more point we all need to understand, is that the mass of the left ventricle is greater than the mass of the right ventricle physiologically. It's just because the right ventricle pumps to a low pressure system and the left ventricle pumps to a high pressure system. That's why physiologically the mass of the left ventricle is greater than the mass of the right ventricle. Okay, and we said that the action potential will start from here, it will come like this and it will spread like this. Okay, now let's consider that the mass of the left ventricle is increased, okay, because of you can say chronic hypertension. Okay, let's consider it has been increased. Now the action potential, which was coming like this, it will divert to the left ventricle. When it divert to the left ventricle, this side lead will show positive deflection, okay, overall, and this side leads will show negative deflection because the action potential is going toward this side and away from this side. See, it is going toward this side and away from this side. Okay, so this side action potential will show negative deflection. Now this side can be seen on lead number 1, okay, and this side can be seen by lead number AVF. Okay, so there will be positive deflection whenever the hypertrophy occur at this side, and when the hypertrophy occur at the opposite side, for example at the right ventricle hypertrophy occur, then the action potential will go more toward this side, okay, as compared to that side. So now the action potential is coming toward this side. The deflection on the AVF now will be positive, and it will be negative deflection on the lead number 1, because the action potential is going away from lead number 1 toward the AVF, so there will be positive deflection. Okay, so now we will see that you can see the normal axis of the heart from lead number 1, 2 and AVF, that is lead number 1, lead number 2 and AVF. Remember that if all the deflections 1, 2 and AVF, if it's all positive deflection, positive mean upside, it means it's normal axis, 1, lead number 1, 2 and AVF, or all upward deflections, which is normal. So the axis of the heart is normal. Now let's see one more variation of normal axis of the heart. Sorry for these hairs. See, when you see the lead number 1 and 2 upward deflection and AVF downward deflection, it still means that these are normal axis. Okay, we actually use this AVF this for we actually use this lead number 2 whenever we are confused. Okay, so along the way we are going to study that whenever we get confused, then we go to the lead number 2, but here actually it's normal. 1 and 2 are upward deflection and AVF is downward, still it's normal axis. Okay, so we studied two things: whenever the deflection of the 1, 2 and AVF is upward, or if 1, 2 is upward and AVF is downward, it's normal axis. Now let's see the left axis deviation, and we studied that the left axis deviation means your action potential is going more toward the left side of the heart. It means that the 1 is going to be deflected upward and 2 and 3 are going to be deflected downward. Okay, it means that it's a left ventricular hypertrophy. See, 1 deflection is upward, 2 deflection is downward, QRS complexes. Look at the QRS complexes. And this is AVF. AVF is also downward. Downward mean the action potential is not going toward this side, it is going toward the lead number 1, and we know that when it is going to the lead number 1 in this paper, when it is going to the lead number 1 left ventricular hypertrophy, it will be upward deflection and it will be downward deflection. You got it? Now look at the ECG. See, upward deflection in lead number 1 and downward deflection in lead number 2. And for confirmation, is it confirm or not, look at lead number 2. It is also downward deflection. Lead number 2, it is also downward deflection. Downward deflection, it means here, here it's also downward deflection. So these two are downward and this one is upward. It means it is left axis deviation. It means that left ventricular hypertrophy. Okay, and right axis deviation, when your AVF is upward, okay, and 1 is downward, it means that action potential is going away from lead number 1. Lead number 1 was showing you the left ventricle, and lead number AVF shows you the right ventricle. So it is going more toward the right ventricle and going away from the left ventricle. Going toward the right ventricle mean right ventricular hypertrophy. And to confirm it, you need to look at lead number 2. Lead number 2 is also supporting this. Okay, lead number 2, positive deflection. AVF, positive deflection. And it is going away from lead number 1. It means it is going away from the left ventricle. And this is known as the right axis deviation. It means that the action potential is going more toward the right ventricle as compared to the left ventricle. It means right ventricle is hypertrophied. Okay, now extreme axis deviation. Extreme axis deviation is that when 1, 2 and AVF, all of them are having negative deflections. See, this is negative deflections predominantly, and AVF negative deflection. So this is actually extreme axis. Now let's see some axis deviation on ECG paper. Look at here, lead number 1, downward deflection. It means that action potential is going away from the left ventricle. And look at lead number AVF, upward deflection of the QRS. It means action potential is going towards the right ventricle. It means right axis deviation. And to confirm it, look at lead number 2. Lead number 2 is supporting lead number AVF. Okay, so this is the ECG of the right axis deviation. It means a right ventricular hypertrophy has been occurred. Look at this ECG now. Lead number 1 deflection is upward or positive deflection, and AVF is downward. It means that action potential is going toward the lead number 1. Lead number 1 mean left ventricle, and going away from right ventricle. It means left axis deviation. Okay, now there is one more method that you can use to find the axis deviation quickly. Okay, and it's a funny way, I know, but it's a very quick way to find the axis deviation. Okay, this is a person standing here. That is his left arm, that is his right arm. Okay, the left arm shows lead number 1 and the right arm shows AVF. Okay, AVF is at the right side. Look at here. Now if the positive deflection is in the lead number 1 and there is negative deflection on lead number AVF, it means right axis is down and left axis is up. So it means it's left axis deviation. Look at here, left upward and the right, which is AVF, is downward. So left axis deviation, left ventricular hypertrophy. Okay, now let's go to the other one. See, left is downward now. Lead number 1 left, it is downward deflection. And look at the AVF, which is at the right side, upward. It means right axis deviation. It means right ventricular hypertrophy. Okay, so it was my own method that I use in emergency conditions to find the axis deviation. And this is the last one, which is extreme axis deviation. Look at lead number 1. Lead number 1 is downward deflection. It is written over here, lead number 1. Okay, downward deflection. Okay, then lead number 2, downward deflection, and AVF, downward deflection. Look at this. So this is known as extreme axis deviation.